geometric sequence 5, 10, 20. If you analyze, this is multiplying by 2. Like 5 times 2 is 10, 10 times 2 equals 20. So 20 times 2 equals 40. And 40 times 2 equals 80. In number 2, this is multiplying by 3, or precisely multiplying by negative 3. So that positive number will produce a negative number for the next term. Now, if you cannot think of the number that is being multiplied, you divide a term by the previous term. Like negative 18 divided by 6, that is negative 3. Again, 6 times negative 3 is negative 18. Times negative 3 is positive 54. Times negative 3 is negative 162. And times negative 3 is positive 486. In number 3, we have 25 followed by 5. So obviously that is dividing by 5. 25 divided by 5 equals 5. 5 divided by 5 equals 1. 1 divided by 5 is 1/5. In number 4, this is dividing by 3. 729 divided by 3 is 243. 243 divided by 3 equals 81. Divided by 3 is 27, and 27 divided by 3 equals 9. In number 5, if we multiply 1 over 64 by 8, that will be 1 over 8. And 1 over 8 times 8 equals 1. 1 times 8 equals 8. And 8 times 8 equals 64. Let's have some more. 2, 6, 18. What's next? This is times 3 again, so 54. Next number? Yes, 162. Number 2. You look at consecutive terms. We have 32, 64. So this is times 2. 4 times 2, 8. Times 2, 16. Times 2, 32. 125 divided by 5 is 25. Or negative 125 divided by negative 5 is 25. 25 divided by negative 5 is negative 5. Negative 5 divided by negative 5 is positive 1. 1 divided by negative 5 is negative 1/5. Next, 48 to become 192, that means times 4. Or you can divide 192 divided by 48 is 4. So 48 times 4 is 192. So going to the left, divide by 4. 48 divided by 4 equals 12. 12 divided by 4 equals 3. Number 5. 256 divided by 64 is negative 4 also. Negative 4. So we multiply by negative 4. 1/4 times negative 4 is negative 1. Negative 1 times negative 4 is positive 4. 4 times negative 4 is negative 16. Now for number 6 and number 7, please give the correct answers. Identify the common ratio in each geometric sequence. 2, 6, 18, 54. What's the common ratio? 6 divided by 2, 3. Number 2, 1 over 16, 1/4, 1, 4, 16. You just take any two consecutive terms that are easy to divide. So you can divide 4 divided by 1 or 16 divided by 4. So the common ratio is 4. But of course, in my example, I got 1/4 over 1/16. Well, just to show you that still you are going to get the same answer, 4. Next, 250, 50, 10, 2. What do you think is the common ratio? Yes, the common ratio is 1/5. Because this is dividing by 5, so the common ratio is 1/5. Or, going back, we have 50 over 250. That's 1/5. You can also have 10 over 50. That is still 1/5. Number 4, what's the common ratio? Right, it's -4. Number 4, what's the common ratio? Okay, that's for you to think about. Determine if each of the sequences below is arithmetic, geometric, or neither. Number 1. So you're going to think if the pattern is adding or subtracting a constant number, then that is arithmetic. If the pattern is multiplying or dividing by a constant number, that is geometric. If neither of this is applicable, then it's neither arithmetic or geometric. Now this is times 4. Okay, so it's a geometric sequence. This is adding +4. Adding +4 is the pattern. Therefore, this is arithmetic. Okay, 3 times 5, 15, times 5, 75, times 5, 375, times 5, 1875. It's multiplying by a constant number, which is 5. Therefore, it's geometric sequence. Number 4. 1, 1, 2, 3, 5, 8. If you add 1 plus 1, 2. Well, is this arithmetic? No. Is it geometric? No. It's neither. What kind of sequence is this? What do you call this sequence? It is Fibonacci sequence. Fibonacci sequence. Number 5. 2x, 3x plus y, 4x plus 2y, 5x plus 3y. Look at the x. We have 2x, 3x, 4x, 5x. It constantly increases by 1x. While for the y, we have here 1y, 2y, 3y. At the first term, 0y. It also constantly increases by 1y. So each term constantly increases by x plus y to obtain the next term. So this is arithmetic. Number 6. Number 7. So these are for you.